Good morning, students. The previous class we have seen about discrete random variable and probability mass function and the cumulative distribution function. So the same results we are going to see today, continuous random variable. Okay, so the continuous random variable, it takes on any value in the set of intervals of real numbers. Okay, continuous random variable takes values within the given interval. For example, interval 0 to infinity. So interval means we have to consider all the real numbers, the set of all real numbers from 0 to infinity. So you will have infinitely many real numbers. So it will takes values within the given interval, means that random variable is a continuous random variable. Okay, see now here see the definition for the continuous random variable. S be the sample space and the random variable, let a random variable x, capital X, is a function from real valued function. It's a function from S to R that takes on any value in a set I of R. So I is called the interval. Then this X is called a continuous random variable if the probability of X is equal to X is equal to 0 for any X and I. Okay, this result I will explain in the next page. Okay, so you see that continuous random variable means it takes values within the given interval. Okay, so next one, we are moving to the probability density function, that is called PDF. For the discrete random variable, we have seen probability mass function. What is it? Probability mass function. So for the probability mass function, small f of x, it is denoted by small f of x, that is equal to P of x is equal to x. What is it? Probability mass function. So here it's a probability density function that is denoted by PDF. It is also denoted by the symbol small f of x only. Okay, so see now that small f of x, that is called probability density function. It having the property, what is the property? P of a less than or equal to x less than or equal to b, that is equal to integral a to b small f of x into dx. You see the definition now. A non-negative real valued function small f of x. So small f of x is a non-negative. It is greater than or equal to 0. Real valued function. So whose values are real numbers. Is said to be a PDF. That is probability density function. If for each possible outcome x belongs to one interval, that is a continuous random variable, of a continuous random variable x having the property P of a less than or equal to x less than or equal to b is equal to integral a to b f of x dx. So the probability density function also, it is denoted by f of x. It having the property P of a less than or equal to x less than or equal to b is equal to integral a to b f of x dx. So in integration chapter you have studied integral a to b f of x dx. What it is? You see that it is the limit where is from a to b, from the on this interval a to b. This is your, what is it? Integral a to b f of x dx. This is the area under the curve and within the limit a to b. So the area under the curve is nothing but probability of a less than or equal to x less than or equal to b. Okay, so see that here we have said integral a less than or equal to x less than or equal to b is equal to integral a to b f of x dx, which means that P of x equal to a. So your x takes particular value a, means how you can write it is equal to integral a to a f of x dx. Okay, so for example, integral p of x is equal to a. X is equal to a, that is for the function that is nothing but integral a to a f of x dx. For example, you consider your f of x as x. Your f of x as x. So if you integrate, what has to come? It is x squared by 2. And if you apply the limits a to a, what has to come? You have to apply the upper limit. So a squared by 2 minus a squared by 2. What's the answer you are getting? It is 0. So for the continuous random variable, we are using the formula to find the probability. This is not probability varies from a to b. That is equal to integral a to b f of x dx. We are using integration. So the probability of a particular value of x is 0. So that only we mentioned in the definition. You see that x is called a continuous random variable if p of capital X is equal to x is equal to 0 for every x and I. Because for the continuous random variable, if you want to find the probability, you have to use the integration. So the integral value of the integral value of the function which varies from the same limit is equal to 0. So that's why we have written p of capital X is equal to x is equal to 0. So that only p of x is equal to a is 0. So the probability when x takes on any one particular value is 0. So therefore, for the continuous random variable, this result holds. What is it? P of a less than x less than b. Here the n points are not included. A and b are not included. Here a is included and b is not included. Here b is included, a is not included. Here both are included. So whether you need not worry about the single point, whether it is included or not in the continuous random variable. So all the four results are same for the continuous random variable. That will be written as integral a to b f of x dx. You need not worry about a particular value whether it is included or not in the continuous random variable. But whereas if you consider the discrete random variable, the equality symbol is very important. If it is included, you have to include. If it is excluded, you should not include that. For the continuous random variable, you need not worry about the particular value of x. So everything is equal. So integral a to b f of x dx. Okay, you see that. Next, the properties of PDF, that is small f of x. So already we have said it's a non-negative. So that's why f of x is greater than or equal to 0 for every x. And here, so for the discrete random variable, have you remembered we have used summation x f of x is equal to 1. I have said the total probability is 1. I have used summation because it's a countable number of values. So we can count it. So we can add. So that's why we have used summation. But the continuous random variable, it takes values within the interval. So it has infinitely many number of values. We can't add all those things. So for that, we have to use the symbol integration. So integration varies from minus infinity to plus infinity. F of x dx is equal to 1. The same thing, the total probability is 1. But for the discrete random variable, you have used the summation. For the continuous random variable, if it is a PDF, that is probability density function, so it has the property integral minus infinity to infinity f of x dx is equal to 1. So that only written here. First one, f of x greater than or equal to 0 for every x, and integral minus infinity to infinity f of x dx is equal to 1. Okay, so next one, you see that the continuous random variable is denoted by the letter capital AX, and whose probability function is called probability density function, that is small f of x, and we have seen the properties also. Next we are moving to the cumulative distribution function. Here it is denoted by distribution function. So it is denoted by the letter capital F of x, that is equal to P of x less than or equal to x. So the formula, these two denotions are same. But here for the continuous random variable we will use the integration. So integral where to where? Minus infinity to x f of t into dt. So it is less than or equal to x. So therefore starting from minus infinity, where it will end, it will end with x. So minus infinity to x, that values are less than x. So minus infinity to x f of t into dt, and a t varies from minus infinity to plus infinity. So this is the formula for cumulative distribution function. Okay, so next one, we have to find probability density function. Probability density function is small f of x, and from the cumulative distribution function, that is capital F of x. If you want to find probability density function, small f of x, if you want to find, you have to differentiate the cumulative distribution function. So small f of x is equal to the differentiation of capital F of x. So probability density function is equal to the differentiation of cumulative distribution function. So using these we are going to do the problem. Okay, first one, the probability density function of x is given by, so you see that the probability density function is given like this. Find the value of k. Okay, first we should know about the given function. You see, it is f of x. F of x having two values. One is kx e power minus 2x. Another one is 0. These two are the values of f of x. When this value, the first value takes, means your x is greater than 0. So when x greater than 0, your f of x equal to this one. For x less than or equal to 0, your f of x is equal to 0. So x greater than 0 means it is from 0 to infinity. So infinitely many values. So it is a, what is it? Your x is a continuous random variable, and here your small f of x is a probability density function. Already they have mentioned the probability density function of x. So it is a PDF. So if it is a PDF, it has two characteristics. One is f of x greater than or equal to 0, and integral minus infinity to plus infinity small f of x dx is equal to 1. So we are going to take this result starting from minus infinity to plus infinity. Okay, so according to your x in two types. One is x less than or equal to 0, another one x is greater than 0. So we have to start from minus infinity. So we have to start from minus infinity to 0 and 0 to infinity. So minus infinity to infinity is splitted as two integrals, minus infinity to 0 plus 0 to infinity. Why we stopped 0? Because it is using 0 only, it is written f of x. So x is greater than 0 and x is less than or equal to 0. So that's why we have written this minus infinity to plus infinity as minus infinity to 0 f of x dx plus 0 to infinity f of x dx. Okay. So in this x value, that is x varies from minus infinity to 0. Minus infinity to 0 means what? X is less than 0. Okay, so when x is less than 0, what is your f of x? That is 0. So in this what is it, interval, your f of x value is 0. So here it is written as 0. So go for 0 to infinity. 0 to infinity means it is x greater than 0. So x greater than 0, okay, your f of x is what? Kx e power minus 2x into dx. So here it is 0. So the whole thing will become 0. So we have to consider this. K is a constant. So this integral 0 to infinity k x e power minus 2x into dx. So in integration we have learned this result. Okay, so integral 0 to infinity x power n e power minus ax dx can be written as n factorial. N is the power of algebraic function x. So n factorial divided by a. A is the coefficient of minus x of exponential function. So you see the power of exponential function, on that the coefficient of minus x is a. So a power n plus 1. So when you compare, this k is a constant, it is taken out. The limit also here it is 0 to infinity. What is the power of ax? It's 1. So therefore 1 factorial, n is 1. So 1 factorial divided by, what is a? A is 2. 2 power 1 plus 1, that is 2 squared is equal to 1. What is 1 factorial is 1. 2 squared is 4. So k by 4 is equal to 1. K is equal to 4. Okay. So see the second problem. The probability density function of x is f of x is equal to, okay, x 0 less than x less than 1 and 2 minus x 1 less than or equal to x less than 2, 0 otherwise. So first we should know about your f of x. So f of x, what is given? It's a probability density function. See, x varies from 0 to 1. 0 to 1, your f of x is x. 1 to 2 is 2 minus x. More than 2 means it is 0. Okay, so this is your f of x is defined here. So first one, what you have to find? You have to find the probability of 0.2 less than or equal to x less than 0.6. Okay, so in the probability density function property, we have defined like this. So P of A less than or equal to X less than or equal to B. It's a area under the curve varies from A to B is equal to integral A to B f of x dx. So here the probability density function is given. So take the first result. In the place of A, what you are having? 0.2. In the place of B, you are having 0.6. So according to this formula, it can be written as integral 0.2 to 0.6 f of x dx. Okay, look at the x value, 0.2 and 0.6. 0.2 to 0.6, everything coming under which interval? 0.2, 0.6, they are less than 1. So therefore, within this interval, x value coming in this interval. So in this interval, your f of x is what? X. So 0.2 to 0.6, your f of x is x into dx. You know how to integrate this? So first you have to integrate x. So the answer is x squared by 2. Okay, and the limits has to be applied, 0.2 to 0.6. So first apply the upper limit. So 0.6 the whole squared by 2 minus 0.2 the whole squared by 2. What is 0.6 the whole squared? It is 0.36 by 2 minus 0.2 means 0.02 by 2. So if it is divided by 2, it's a 0.18 minus 0.02, that is equal to 0.16. Coming to the second subdivision. So P of 1.2 less than or equal to x less than 1.8. So it can be written as integral 1.2 to 1.8 f of x dx. What is 1.2, 1.8? Comes under within which interval? So here 0 to 1. Our limit is 1.2 to 1.8. So it is greater than 1 and less than 2. So you have to write 2 minus x. So within this limit, your f of x is 2 minus x. Now what you have to do? 2 minus x has to be integrated. If you integrate 2, it's a constant. So therefore, it has to be integrated with respect to x. So that is 2x minus x. If you integrate, it is x squared by 2. And you have to apply the upper limit. So 2 into 1.8 minus 1.8 the whole squared by 2 minus Why? It's upper limit minus lower limit. Lower limit is what? 1.2. So 2 into 1.2 minus 1.2 the whole squared by 2. So 2 into 1.8 is 3.6 minus 1.8 the whole squared is, it is 3.24 divided by 2. Minus 2 into 1.2 is 2.4 minus 1.2 the whole squared is 1.44 divided by 2. If it is divided by 2, the answer is 1.62 minus 2.4 minus, if it is divided by 2, 0.72. So if you calculate, your answer is 1.98. Here you will have 1.68. If you subtract, your answer is 0.3. Coming to the third subdivision. What is it? P of 0.5 less than or equal to x less than 1.5. So it can be written as integral 0.5 to 1.5 f of x dx. Okay, see, look at this, 0.5 to 1.5. So in our problem, see how it is classified, 0 to 1. So x value is less than 1 means you have to use x. And x is greater than 1 and less than 2, you have to use 2 minus x. Now you see this value, lower limit is 0.5, it is less than 1. But the upper limit is 1.5, it is greater than 1. So the lower and the upper limit, they are in different intervals. So how you have to split this as? First you have to write 0.5 to 1 f of x dx plus 1 to 1.5 f of x dx. So 0.5 to 1. So those values are less than 1. So for that, your f of x you have to write as x. So here it is x is written. 1 to 1.5. Those values are greater than 1. So greater than 1 and less than 2, you have to use 2 minus x. So here you have to use 2 minus x and it has to be integrated. If you integrate x, it is x squared by 2 and the limit is 0.5 to 1. If you integrate 2 minus x is 2x minus x squared by 2. The limits varies from 1 to 1.5 and you have to apply the upper limit here. So it is 1 squared is 1 by 2 minus 0.25 by 2 plus. So here, so this is the upper limit minus lower limit. In the same way, here also you have to apply the upper limit. So this part is the upper limit minus here it is the lower limit. So it is 1 minus 0.25. So it is divided by 2. So 1 minus 0.25 is 0.75 divided by 2. Here 2 into 1.5 is 3. Minus 1.5 the whole square is 2.25 divided by 2 minus here 2 minus 1 by 2. If you take LCM, 4 minus 1 is 3 by 2. Okay, so you have to take LCM. So here your LCM is 6 minus 2.25. So if you subtract, it is 3.75. So 3.75 minus 3 is 0.75. So already here 0.75 is there. 0.75 plus 0.75 divided by 2, that is equal to 0.75. So here we have used the formula. What formula? If a probability density function is given, if you want to find the probability where P of A less than or equal to X less than or equal to B, you have to use the formula integral A to B f of x into dx. Okay, coming to the third question. Suppose the amount of milk sold daily at a milk booth is distributed with a minimum of 200 liters and a maximum of 600 liters. With the probability density function they have defined. It's a small f of x, so it's a PDF, probability density function. If it is k, when x varies from 200 to 600, that is, it is greater than 200 and less than 600. Otherwise, your f of x is equal to 0. So the three results has to be found. First one, the value of k. So here, what is given? It's a probability density function. So with probability density function, so take that result. If it is a probability density function, it is non-negative. That is f of x greater than or equal to 0. And integral minus infinity to plus infinity, f of x dx is equal to 1. So it varies from minus infinity to plus infinity. See that minus infinity to plus infinity, f of x dx is equal to 1. Okay. So see now in our problem 200 to 600 only the value is k, otherwise it is 0. Okay, so it is defined like that. So how it will be splitted? So it is starting from minus infinity to 200 plus 200 to 600 plus 600 to infinity. Okay, what here you have to write f of x dx, here also f of x dx, here you have to write f of x dx. You see that minus infinity to infinity I have split it as 3 integrals. One is from minus infinity to 200. Why I stopped at 200? Because here in our problem 200 to 600 range your f of x is k. So I stopped minus infinity to 200. Next 200 to 600. Next 600 to infinity. So minus infinity to plus infinity is covered here. Okay. So minus infinity to 200. You see that it is given 200 to 600 only. Your f of x is k. Otherwise it is 0. So up here in this interval your f of x is 0. In this interval also your f of x is 0. So therefore these two values are 0. So we can consider only integral 200 to 600. What is that? K dx is equal to 1. So k is a constant. It has to be taken out. And if you integrate, integral dx is x. So kx limits varies from 200 to 600 is equal to 1. So k is a constant, it is taken out. What is remaining? X. If you apply the upper limit, it is 600. 600 minus 200, that is equal to 1. So k into 400, that is equal to 1. K is equal to 1 by 400. We have written. So find the value of k. So next one, the distribution function. So what is distribution function? Capital F of x we have to find. That is the cumulative distribution function for the continuous random variable. For the discrete random variable means we will add the present probability with the previous probabilities. Here we will see how we have to do. So what is the formula for the distribution function? Capital F of x, that is equal to P of x less than or equal to x. Less than or equal to x means starting from minus infinity to x, f of t into dt. So this is the formula for cumulative distribution function. See now, here we start from all the intervals we have to find out. So starting from minus infinity to plus infinity we have to find out. So according to this f of x, so we have to write the interval, what is it? Minus infinity to 200 and 200 to 600 and 600 to infinity. So we are going to discuss, we are going to find capital F of x in 3 cases. One is minus infinity to 200, open interval, minus infinity to 200. Next 200 to 600. Here I have used closed bracket because you see that your x is here 200 and 600 is included. So that's why I have included. So the next one is what? 600. Third case, what is it? It is 600 to infinity. So we are going to find capital F of x using 3 cases. One is x belongs to minus infinity to 200. Next, x belongs to the closed interval 200 to 600. Third case, when x belongs to 600 to infinity. Okay, you see now, first case. See, what is your capital F of x? Your capital F of x formula is integral minus infinity to x f of t into dt. Okay, so which interval are you going to find? Now your x belongs to x. No, x is not a single number. It is a interval that is varies from minus infinity to 200. Okay, so what we are going to find? We are going to find capital F of x. So according to the formula, we have to start from minus infinity, where you have to end x. X is not a single number. If it is a single number, 200 means you can stop to 200. But x itself is a interval. So that's why I have written x only, because I have to complete this limit. So minus infinity to x. Now your x is what? X also in the same interval, that is minus infinity to 200. So here I have to write f of t into dt. So within this limit minus infinity to x, your x is what? Minus infinity to 200. So we can consider which interval? In minus infinity to 200, what is your f of t? So according to the definition, your f of x is only 200 to 600 only, it is k, otherwise it is 0. So therefore here your value is 0. So your capital F of x is 0 when x belongs to the open interval minus infinity to 200. First case is over. You see again. When x belongs to minus infinity to 200, f of x is minus infinity to x. Why I have written x means the formula, the limit is minus infinity to x. So in that your f of t is 0, so it is 0. So next case we are going to consider. What is the next case? When your x belongs to, what is it? 200 to 600. So here in the problem it is included, so I use the closed bracket. But for the continuous random variable, you need not worry about the single point. Okay, so here the closed interval I have written. Now what I have to write? Just listen carefully. Capital F of x. What is the formula? I have to start from integral minus infinity, where I have to complete x. Okay, so minus infinity I have to start where I have to stop, because your x varies from where to where? 200 to 600 only. So before that your x is not included. So I have to start from, according to the formula, I have to start from minus infinity, then 200. Because in that your f of t is different, isn't it? Plus, next I have to start from 200 to, I should not write 600 because I have to stop x. Your x varies from 200 to 600. So I have to start from 200 to x, f of t into dt. Okay, see that I covered the limit minus infinity to x. Okay, if x is a single number, 600 means here you can write 600 very well. But x is the closed interval. It takes infinitely many number of values. So therefore 200 to x we have to write. So then only according to the formula we will start from minus infinity and we completed on x. So you see that within this interval of x, your f of t is what? 0. But 200 to x, your x belongs to 200 to 600, isn't it? So above which interval will come? 200 to 600 has to come. So in that interval, your f of t is what? It is k. Okay, if you integrate with respect to t, it is kt. And the limits varies from 200 to x. Okay, so see now here I have written minus infinity to 200 f of t dt and plus 200 to x f of t into dt. So here it is 0. Here you will have k into what has to come here? It is dt. What is? It is dt. So if you integrate here, you will have t. Okay, if you apply the limit, upper limit, it is x minus, if you apply the lower limit, it is 200. So k value is what? 1 by 400 into x minus 200. So second case is over. Next we have to find out what it is. The case 3, x belongs to 600 to infinity. It is more than 600. So here we have written the formula. So starting from where you have to start? Minus infinity. And your x where it is? 600 to infinity. So we have to start from minus infinity to 200. Next 200 to 600. Why I have written 600? Your x is more than that only. So therefore 200 to 600 plus 600 to, you should not write infinity, you have to write x. Then only the formula limit has to be covered, starting from minus infinity to x. Okay, so within this limit your f of t is 0, so that this term is 0. 200 to 600, your f of t is k into dt. So k, if you integrate dt, that is t, and the limits varies from 200 to 600. And here 600 to what is it? Infinity, your f of t is 0. So this is also 0. So when you apply the upper limit minus lower limit, it is 400. So 1 by 400 into 400 is equal to 1. So we have to write the f of x. What is your f of x? So you have to write the 3 intervals. One is minus infinity to 200. Second one 200 to 600. Next is 600 to infinity. Otherwise you can write open interval, closed interval you can use. So in that your capital f of x is what? It is 0. So the next case, your capital f of x is what? 1 by 400 into x minus 200. The next one, your capital f of x is 1. So it is written here. This is called cumulative distribution function. Okay, so in this problem, the third subdivision, what is asked? You see that the probability that daily sales will fall between 300 liters and 500 liters. So it is between probability, we have to find the probability, that is P of your daily sales. Daily sale is denoted by the letter X. Okay, so it is between 300 to 500. So we have to find out probability of 300 less than X less than 500. So see now here you have to decide which function are you going to be use. So if you use small f of x, that is probability density function, means you have to use the formula integral a to b f of x dx. Okay, you have to integrate and you have to apply the limits. If you use probability density function, that is small f of x, means the answer for this question is integral a to b f of x dx. Or you have found the capital F of x, that is cumulative distribution function for the continuous random variable. If you want to use the cumulative distribution function, you can go for P of A less than X less than B. That means capital F of B minus capital F of A. That is second result. That is a upper limit F of B minus F of A. So here you have to integrate and apply the upper limit. So you have to avoid integration. If you have capital F of x, you can use this formula. Here in this formula you need not integrate. So I have chosen the second one. Probability of 300 less than x less than 500. So your A is 300, your B is 500. I'm going to use capital F, that is cumulative distribution function. So what is the formula? F of B. So F of 500 minus F of 300. So 500. Now your x value is 500 and you are going to use capital F of x. You see the limit. 500 will come in which interval? So this is minus infinity to 200. Here this is 200 to 600. So the 500 will lies between this interval. So for this x, what is your capital F of x? X minus 200 by 400. In the place of x, what is your x is now? 500. So you have to choose 500 minus 200 divided by 400. According to here, you will in between you are having minus F of 300. So 300 also it is greater than 200 and less than 600. So it has to come within this interval. So you have to choose your capital F of x as this one. So in the place of x you have to substitute 300. 300 minus 200 by 400. When you calculate, it is 3 by 4 minus 1 by 4. 3 by 4 minus 1 by 4 is 2 by 4. The answer is 1 by 2. If you can use, you have to use the probability density function. What is probability density function? In the starting, the problem is given. So this is your probability density function. Okay, so we have found what function? Cumulative distribution function. So if you want to use that, the formula is f of b minus f of a. Thank you, students.